Alright guys, so check it out. You guys are all busy drawing this lower right section. So everybody's trying to get this guy sketched in where the spinning wheel of death is. Okay? And then I'm going to drag a picture over to show you guys what that should look like. Alright, so you guys might need to pause the video and then zoom in on this guy, but if you guys notice, you're supposed to draw all black. Okay, you don't draw any of the red, that's just clues where things go. And then the blue is actual measurements, so you can get this guy in there proportionally. Today on the video, you're gonna see that when I write stuff in, it doesn't fit, but I've done this on the same page as you guys, and it does when we're not using the Promethean board. Okay, so I'm gonna take that back off. Cool. Alright, you guys ready to get started? Maybe a little bit. Alright, you guys, the first thing I'm going to do is zoom into the area we're working on. Okay. Which is... Just kidding. Stop that. Cool, and then we'll go down here, and hopefully that'll go away. Okay, does everybody see where we're working now? Great, this is where we're going to be working. Okay, you guys, so I just want to remind you guys, a couple days ago I had to draw a big crazy panda bear knocking down trees, and everyone left class with no understanding of what's going on, and the next day we were able to break it down. This is going to be very similar to that, okay? So we're going to draw our stuff, and then you guys will go home scratching your head, and you guys will come back tomorrow and we'll knock this out real quick, and you'll be amazed at how well you guys can do stoichiometry. So, stoichiometry, you guys might notice that you guys have done 3 bars for dimensional analysis. Stoichiometry is the fancy chemistry name for dimensional analysis. Is this going to be simplistic dimensional analysis? No, look at how many boxes we have. If you guys look up here, we have 1, 2, 3, 4, 5 boxes. Down here, same thing. Okay, we're going to have to go from one thing to another, back to the other, and then back to the final. Okay? But it actually works fairly easy. Fairly easy. Okay, so start with this. We're going to write down stoichiometry because that's what we're doing. So I'll write it up here for you guys. Let's see, I should probably grab my sheet so I make things the right way. Okay, so stoichiometry right across the top here. We have S, T, O, C, H. Okay, stoich. E, so I-O-M-E-T-R-Y. Stoichiometry. Okay, stoichiometry. Okay, so stoichiometry is basically dimensional analysis, but it's going to go from known to an unknown, and we use it when we're doing chemical equations. Now, if we just decided in a chem lab to take stuff and mix it without knowing what the products would be, we could literally blow up our chem lab just because of space. Okay, so the idea is we will either give you guys an amount of something, we'll just say an amount of something for now. Okay, so we will give you an amount of something, we'll say how much of this is it going to make. So we have a known amount of something, and we need to find an unknown amount of something else. So here's how this works, okay? When you guys do this, you guys are always going to put the known right here. K-N-O-W-N, okay? Our known is going to always go in the first box, okay? And then the known is going to give us a number we know, which I'm going to call the mole we know, which this is going to be a mole of something. And we'll talk about what a mole is later. Okay. Now, once we have a mole in our second top space here, we're going to use a ratio in both these next one. So we're going to have an R-A-T-I-O. We're going to have a ratio. Okay. And a ratio is just a fancy word for a fraction, correct? The ratios we're going to use are going to come from a balanced equation. So remember how you guys all learned how to balance equations? Now you know how to do that. We can actually do some chemistry with it. Okay. Once we have a ratio, we're going to go with the mole we don't know. So we're going to attempt to find the mole we don't know, okay? And in doing that, we should be able to find the unknown. It's just that simple, kids. We go from known to a mole. We use a ratio to the unknown mole to the unknown amount of whatever we're looking for, okay? Just know that's a very vague, poor description of what stoichiometry is. But we're going to use a dumb diagram to help you guys remember this, okay? Truth is, a lot of you guys are going to chemistry. You won't remember any of the mess I'm teaching you. you'll just be really good at what you do, and you won't understand it's a dumb panda's fault. Or maybe it's a pear with a knife. Or maybe it's that mole on the board. Okay, we'll move forward. All right, here we go, ready? So we're gonna go with, start it out, we're gonna go with what we give you guys. So I could say, hey, I'm gonna give you 10 grams of H2O, but I want you to split it and tell me how many grams of hydrogen we get. That's something someone could commonly do in a lab, okay? So one thing we use for our knowns is grams. Okay, grams. So when we use grams, we are gonna use a what? A balance, right? This is my old school balance. He's kind of frowny face because he's doing stoichiometry. Okay, and we can get grams of two things. We can get grams of solids, and we can get grams of liquids. Okay, solids or liquids. Okay, now we talked about solids and we talked about liquids. So let's see about what else could we do? Gases. Now we do liters. Okay, so liters are for gases. So if I told you I had 10 liters of hydrogen, how much water could we make? The given would be we have 10 liters of hydrogen. Okay? Okay, so the next one are unusual. Okay, the next one is particles. We have particles, and the two types of particles we typically use are what's that? It's an atom. So I could say we have 150 bazillion atoms of this. Now I want to know how many of it it'll make. Okay. Or we use the other one we use sometimes is going to be, I almost clicked on the white box. That probably wouldn't have been helpful. Okay. Is going to be it's going to be molecules. Okay? So we could have particles in the form of atoms or molecules. Okay? Now the funny thing is, all these things that we have as unknowns, as knowns, we're also going to have as knowns. Okay, so all the way on this side of our conversion, we're still looking for grams. Okay, but let's do a different scale here. Let's do a balance that we might use more frequently. No, it's not the enterprise. It's a triple beam balance. Very good, you guys. So this guy might be here, and here, and here. Okay, so still grams. We're still getting solids. And we're still getting liquids. Okay, solids and liquids. Okay. Let's see here. Now what's funny is normally when we have gases transferred to a lab, it doesn't come in balloons, although that would make chemistry a lot more fun. Okay, we usually have it come in bottles, right? And those bottles come in liters, right? So, once again, we are still looking for liters. And that is for gases. Okay? And then we also will sometimes find, let's see, let's get this way. We might be looking for hydrogen, which is a what? Atom. Or we might be looking for H2, and then we'll just do a different color for O, which is a molecule, right? And all these both are considered what? Particles. We have atoms or molecules. Okay? So the cool thing is now, you guys know what we start with and what we end with in stoichiometry. And the cool thing is, I could give you grams of something, and then you could tell me how many particles are in it. I could give you liters of something, and you could tell me how many grams it would produce. Okay? I could give you guys particles, and you could tell me how many liters of gas it would produce. Okay? That's what stoichiometry does for us. Stoichiometry does that for us. What do you got?
How can you use liters versus a volume to measure gases?
Because we put it at STP. I don't remember what STP stands for, but let's say standard test pressure. Sure, but we'll use STPs for that, okay? And so standard test pressure ensures us that we have the same amount every time. If we did the experiment at sea level or the mountains, that'll be all jacked up, right? Yeah. So we have to have a standard test pressure. Okay, also, we could use a ton of gas if we crammed it into a 1 liter bottle that could hold a lot, versus like a water bottle, which will explode if you sit on it, correct? Okay, all right, cool. Very good question. All right, guys, so now I'm going to talk to you a little bit about how stoichiometry works, okay? So the first thing we have to do is we need to understand that when we go from an unknown, we're trying to go to a mole, okay? And so the moles look a little bit like this, scientifically speaking. And this mole is popping his head up out of the hole, and we can see him, which makes him the mole we know. And so he could say things like, my number is, because we know him. So we know what his molar mass is. There's a little clue there for how we're going to be doing this. Don't you guys love that I drew it on the board so you guys can have a better drawing? Now what's funny is we also need to convert eventually to the mole we don't know. And you'll notice he's under, because we don't know who he is because he's hiding from us. So we have our mole over here. Okay, and he is very similar to the other one, but we'll figure out some stuff about it. Okay. So we now have our 2 moles. We have our known mole, which is like, my digits are the same, bro, call me. And the other mole, and he's like, wait, what is my number? I'm not sure I want to give that to you. What is my number? Okay, so this is the unknown mole, which is the very last thing we'll find before we find the amount we need. Okay? Okay, now, how do we go from mole to mole? Well, we have a balanced chemical equation. When we have a balanced chemical equation, we have ratios. Those ratios come in the form of coefficients. So, in this box, we're going to use the coefficients. Coefficients, or the molar, M-O-L-A-R, ratio, R-A-T-I-O, the molar ratio. Okay? The top word is coefficients. Coefficients. Remember, what are the coefficients?
Before the letters.
They're the numbers before the symbols. Okay, the numbers before the letters. Okay? Cool. All right, so now we're getting this filled in a little bit. We just have to talk about how we go from each one of these to the correct moles, because we have to have our translation, right? So here we go. So we're trying to go from grams, okay, to moles, okay? We are trying to go from grams to moles, okay? So this is the mole we know. Why? Because he's up above ground. So the mole we know always goes on top. So we're going to have 1 mole up here, okay? And the 1 mole, you'll recognize, is already on top, right here, okay? But the number that goes underneath him is the molar mass. M-O-L-A-R-M-A-S-S. Your molar mass. Okay? Now, there's this little box above this. Guess what this box represents? That's right. It's a box from the periodic table. And so, right here, you're going to have a little tiny number symbol because there's a number up there. We're going to have a big X and a little x because that's the symbol. Very good. And then we're going to have a big M and another big M. And what does that represent? Molar mass. You guys, when we're looking for the molar mass, that's where we find it. Okay, so if we had hydrogen, we might have grams of hydrogen up here. Okay, so we could have grams of hydrogen here, and then we have 1 mole here, and underneath here, we're going to actually write 1.009 or 1.099, whatever the molar mass is. Okay, that's our first conversion factor. Yes?
What's at the top? The X?
So I have a number sign right here,
Okay.
and then I have a big X and a little x, which just represents a generic symbol, and then I have MM, which actually stands for the molar mass. Okay, and once again, you guys should be able to write them a little clearer on your paper, because you got a little more room. Promethean board limits me to this size. Okay? All right, so next, let's talk about how we get liters. Okay? So liters are going to come to this one. Oh, that's red. Don't like that. Freaks me out, man. He didn't like that either. Now we have a spinning wheel of death. There it goes. Okay, cool. All right, so we're going to go from liters. Okay. Now the trick here is it's the mole we know. So where does he go? Up top. So we're going to write 1 mole above this. Okay. And then below it, because the gas laws, which we haven't learned yet, we'll be doing that next. We are going to have 22.4 liters. And then you remember you were asking about pressure? They always write parentheses STP. Okay? STP. And I think that's standard test pressure. I'll have to double check that one because you kind of sprung that one on me, but that was a good find. Okay? Now we could go from particles. So particles, I'm going to go from here to here. Okay? And for those guys, they're super convenient because we get to use one of these guys. Aha, I heard it. It's an Avogadro. It's Avogadro's number, right? So on the top here, we're going to have 1 mole, because that one's the mole we know. He lives on top. And underneath it, what's Avogadro's number?
6.0.
So 6.022 times 10 to the 23rd. Okay, 6.022 times 10 to the 23rd. It's an Avogadro. Okay, so if we were doing that one, okay, we would put whatever we have here, 27 whatever hydrogen whatever's, and down here we would have to do 6.022 times 10 to the 23rd. Okay. Now the cool thing is, on the other side of this, they're just flipped, because the mole we don't know goes where? On the bottom. Okay. So we can add these guys back over here. So we can go from here. Oh, just kidding. Let's go from here with a pencil. Okay, so we can go from here to here. Okay, where's the mole go? On the bottom, because he's hiding from us. He's the mole we don't know. Okay, and then up top, it's going to be molar mass. Okay. From here to a gas, he's the mole we don't know. Where's he going to go? 1 mole. Do you guys see how I'm writing that just like here? See up here we have our 1 mole we don't know. Okay, he goes on the bottom. All right, and then above this one, what's the number we put up here? 22.4 liters STP. Standard test pressure, or whatever that stands for. Okay, and then the last guy, we're going to go down here again. Okay, and the mole goes on the bottom. Right? We have our fun little guy over here too. Okay, and what's the number for that? Avogadro's number? 6.022 times 10 to the 23rd. Okay, what you guys now have is this amazing chart that's going to help us do everything you need to. It's going to set up your stoichiometry every time. We always go from a known to an unknown, okay? Tomorrow when we come in, we're going to put a chemical equation right here, okay? We're going to balance that chemical equation, which would give us what? What's the balanced equation give us? The molar ratios, okay? And then I'm going to give you, say, 10 grams of something. So that gives us grams, right? So we'll start both of these. This guy will be known 10 grams. This guy will be known 10 grams. And I'm going to ask you, how many grams of something else will it make? So you'll put how many grams of something here. And then I'm going to ask you, how many atoms of this will it make? Or how many molecules of this will it make? And that's going to go right here. So we can solve for grams. So we're going grams to grams, or we're going grams to molecules. I could just as easily do liters. We can figure that whole mess out. Okay, does that make sense to you guys? All right, so this is your basis. Okay, let's see, what am I missing over here? I didn't fill out the rest of this guy. What goes up here? Number symbol. What goes underneath it? XX. And then what goes down here? Molar mass. Okay, molar mass. Cool. And then which one do we use? We use the molar mass. Okay? I really like my moles, not gonna lie. Okay, you guys, so check it out. Here's what you guys have next. So now you guys went and did all these outlines, right? We're gonna start bringing these outlines into it, but we're gonna start doing your practice. Okay, you guys have, it's basically a quiz, but I think it says 12/3 atomic structure. Okay, you'll click on that Moodle. It's got 10 questions. Take it until you get 100%. If you're happy with your 90%, know that I'm gonna give you a 7 out of 10 for that 90%. If you get less than a 7 out of 10, I'm gonna give you whatever your score is. Okay, these should be 3 points. You guys should get 100% on this. Okay, and I think I made the assignment worth 20 points because I want to make sure it still affects your grade. But you guys are going to have one of these to practice. The questions are simplistic. Here is an atom. How many protons does it have? How many neutrons does it have? How many electrons does it have? This is 6th grade stuff. Okay, so you guys just take those over and over and over until you guys get a 10 out of 10. Like I said, there's only 10 questions on it, so it should be really easy for you guys. Okay, all right, so we're going to get started on everything else. I'm going to close this out. Maybe.